Hello, and welcome everyone. Thank you for being here today. This session is a part of our ongoing webinar series from CIGen, a software engineering company that helps teams build, modernize, and scale products through cloud-first architecture, DevOps practices, and full-cycle development. With over 50 specialists and clients across the US and European Union, we support companies in creating software that's both future-proof and easy to evolve. Today's topic is from mobile to everywhere, how to build a unified cross-platform app with Flutter, Go, and MongoDB. We're going to look at what it really takes to build one product that runs consistently across mobile, web, and desktop, all from a single shared code base. And let me introduce our speaker today, Dmytro Afanasiev. His background is in full stack engineering, working primarily with .NET, Angular, and more recently Go for high-performance backend services. And over the past 7 years, he has built distributed systems for logistics, finance, healthcare. And he is also a Microsoft certified engineer and has been part of multiple modernization projects where cross-platform requirements played a key role. Just to remind you, please feel free to write your questions in the Q&A section here in Teams or in the chat. And at the end of the session, Dmytro will definitely try his best to answer them. So I think it's time for us to get started.
Thank you, Lisa. Let's quickly look at our agenda for today. So first we'll discuss the trends in the modern software development, what you want to pay attention to when you're, if you're planning to build a new app for your business, or and we'll share some of our experience at CIGen on how we've approached these kinds of projects over the years. Specifically, we'll focus on the cross-platform way of implementing front-end clients. This is something that we've historically had a lot of experience here at CIGen, and we'll also briefly touch on that. And also how in recent years web-only applications have been catching up and have provided a very common alternative to either both cross-platform and fully native apps. Why we'll cover why web-only approaches sometimes fall short of the needs of some businesses. Then we'll have a look at what options do you have if you decide to go with the cross-platform route. I guess our main presentation here is to describe the preferred tech stack that we have come up with, that in our experience provides the best cross-platform applications for your needs, together with a modern microservice-based backend that can be either cloud native or run on premise, and we'll talk about why it is also has become a preferred way of development over the last few years, and what would its advantages be to your business. Then we'll have a quick live demo of a to-do list application, sort of like a Kanban board that I've prepared using this stack of Flutter on the front end and Go and MongoDB on the back end. Then we'll again summarize the impact and the benefits of this kind of approach, and we'll have a bit of time at the end for a Q&A. So let's proceed with that agenda. to talk about, if we want to talk about trends in today's software development industry, I guess what the conclusion that we've come up to is that the problems and the trends that were there maybe 10, 20, 30 years ago have never really gone away. Sometimes they became even more important, but also we have much more ways to solve them. So, for example, the platform fragmentation has been increasing, but again, this has been the problem forever. One of the first issues that the software developers have been thinking on is how to make a single code base run on multiple platforms, multiple types of devices. You can think about, for example, one of the biggest first attempts of doing that was Java back in the 90s. And the idea there was that you would create a virtual machine that you'd port ahead of time to all of your target platforms. And then your Java code would be able to run everywhere on every platform that has a virtual machine version for it. And this has been a very successful approach since then. There are, as you know, billions of devices that run Java. Most commonly, maybe the ones you interact the most with are Android smartphones, but they go way beyond that, and mostly in places that you really rarely even think of. But this goes to show that the demand for cross-platform development has been there forever, and now it hasn't really gone away. I guess the new trend that we have had recently was the use of AI tools. You might not immediately see why what this would have to do with cross-platform development, but actually, if you have a unified code base that's running the same framework and has code written in the same language everywhere, or maybe a small set of languages, it's much easier to use AI tools to improve your performance on that project. And of course, the expectations now are higher than ever because of these AI tools. And if you had a single code base, you're able to use these tools much more efficiently, and especially if you're running a local LLM for your development purposes, it's much easier to train it on one framework rather than multiple for each platform. But of course, the reason why cross-platform frameworks haven't taken over yet is performance and UX concerns. It's also always been a high priority for businesses, but we will demonstrate today why this issue has become much less visible on cross-platform frameworks over the last few years with the recent development advances. And lastly, as we mentioned, microservices are very important for cloud-native deployments, which are very in high demand right now, and they also ensure reliability and scalability of your services. So just to quickly discuss why we at CIGen think that cross-platform solutions are often preferred. So with web-only apps, you obviously have an advantage of there being only one code base, because it's kind of a similar story to Java in that everything that has a browser supported for it will run your web application. So that's the ultimate goal of cross-platform development. But it's also the biggest weakness of a web-only approach, because your capabilities are very limited by browsers, especially with the modern security threats. Browsers are often very limiting to your application and to what it can do with the device that it's running on. And as opposed to that, cross-platform frameworks offer full access to your device capabilities, but also in recent years have been achieving close to native performance. And so both of these things are important, may not be important in some cases, but are required in others. And I think a good example of that also from the past is when the first iPhone came out, the original idea for it was that it would only run web apps in addition to its built-in operating system. And the first iPhone didn't even have an app store because of that. But soon Apple realized that web apps could not provide all of the for all of the needs that businesses and customers have, and they had to also provide an API for developers to make native apps for iOS. And cross-platform frameworks evolve upon that and allow you to make those same native apps, fully native apps, using a single code base. And so what the latest generation of cross-platform frameworks was aiming at was to target as many platforms, offer native performance and full access to capabilities, but make as few compromises on UX and on performance as possible. And here we have some options that you may choose when if you're considering making a cross-platform app. So historically at CIGen, we've had the most experience with .NET MAUI, which is Microsoft's cross-platform framework based on .NET. It was previously known as Xamarin Forms. Back then, it was actually based on Mono, on the open source version of .NET. But since .NET itself has become open source and cross-platform, the Xamarin has evolved into .NET MAUI. But from developers' perspective, they are very similar. And we've been able to achieve quite a nice level of native integration with Xamarin and MAUI. We've produced some very interesting projects using it. Yeah, it definitely has its place if you're considering it, especially if you and your team are already familiar with .NET. But the the concern with it is its use of native components for your UI, which is sometimes useful, but mostly what you end up with is that you don't have a guarantee of that your app will look and feel the same across different platforms, and that's often not a good experience for your users. And another point is that in recent years it hasn't been as well maintained and documented as other framework options, but still it's still used by a lot of projects to this day, and it's an option to consider when you look at considering the options for the cross-platform framework. Another probably one of the most popular frameworks is React Native. It's very similar idea to .NET MAUI, except that it's based on the web React framework and on JavaScript and TypeScript, and kind of similar to MAUI. It's a good option if your team already has web developers. That makes for quite an easy transition to React Native and to expand to other platforms like desktop and mobile. But it has the same problem as MAUI in that it also uses native platform components, and you need to put extra effort into ensuring that your app is performant and the UX is consistent across platforms. Another popular option, just that's worth mentioning, even though it's not entirely cross-platform, is Electron. It's been used in a lot of big name projects like Visual Studio Code and I think Teams, though not that sure on that last one, but definitely in VS Code. It's also a web-based framework, but it allows you to make fully native desktop apps with full capabilities. And in my experience, the Electron apps that I've used have been very nice to work with. So if mobile apps are not your priority, if you need targeting specifically desktop use cases, then it's a very nice option to consider. But what we'll be looking at today is Flutter. It's a framework by Google, and it's using its own framework and language called Dart, which architecturally is very similar to .NET in that it also runs in a virtual machine, and the Dart language itself is very similar to both C# and something like TypeScript. It's object-oriented, kind of follows most of the modern practices for language design, also quite pleasant to work with. But the greatest benefit of Flutter and how it really helped to shrink the gap between native and cross-platform solutions is that it uses its own Skia rendering engine to draw the UI. And because of that, because it does everything pixel by pixel on all platforms, you are guaranteed to have almost exactly the same UI on whatever supported platform that you're on. And the UI design itself is also made much more easier and flexible because of that. We'll see in the live demo exactly why, what kind of benefit it provides. But I think that's really the main feature that puts Flutter above the other options that we've discussed. And you can see it in statistics as well, in that as of 2023, Flutter has been the most popular cross-platform framework, almost pretty much on par with React Native. And we haven't really found the most up-to-date statistics for it, but I'm sure that it's still not far behind because Flutter is being very actively maintained, and Google in general is known for providing one of the highest quality development tools, and Flutter is no exception to that, as we will see. Yeah, just to go over once again why we chose Flutter for this demo and why we think it's the best choice for a modern software project is because it produces fully native apps on all platforms, on mobile, web, and desktop, while still ensuring that you get consistent and performant user interface across all platforms. And you also have Google's support with the ecosystem, with DevTools, and with community. And also there are quite a few big projects that have been using it over the last few years. So I think at the end of the demo, you will see why we think so highly of it and why we think it's a great choice for a front-end client these days. And to quickly go over the backend part of modern software projects, I think there are quite a bit more options to consider there. So the ones that we have picked here are not exactly, well, are not the only ones to consider, definitely. They're also maybe specific to your requirements or to your team skills. But we still feel quite strong that it is a good place to begin with if you're developing your app from scratch. And the reason for that is with a language like Go, you take an entirely different approach to designing your backend, which is more focused on simplicity, on performance, and on concurrency. So that makes it very, very well suited for microservice architecture, because you don't want your web apps to be overly complicated and don't want to have them several layers of classes and inheritance and abstractions to all packaged in a single web API. And Go is suits much better for that because it kind of forces you to think in smaller chunks when you're designing your backend and to maintain proper separation between the areas of concern. And that's mostly because Go is not an object-oriented language like Java or C# or JavaScript that are typically used for backend development, but a structural one, kind of more like C. And that's why you don't really have an option to create complex class inheritance structures. You have to keep things simple. And if you do this correctly, if you approach this with a correct mindset, you will you'll be able to make a much more reliable and easier to maintain ecosystem for your software project. And to go with that, I think one of the best choices for a database in that context is MongoDB. It's very well suited, particularly for microservice deployments, because it has a flexible schema, which means that you don't have to coordinate all the time the schemas between microservices, and it makes stuff like migration easier since it's a NoSQL database. And yeah, and also the scaling and reliability aspects are also very strong with that with MongoDB. And there is, speaking of DevTools and ecosystem, there are ready-made Mongo drivers specifically for Go, which in my experience have been quite easy to use. And talking specifically about Mongo, they have great documentation. So if you've never worked with Mongo or NoSQL databases in general before, I think you should find it easy to learn in which ways they differ, and I think it will be easy for you to see the benefits of it. To put this all together as a microservice deployment, we can use Docker, which is of course the standard tool for this. You can once you have it set up, you can easily deploy it everywhere, either locally or in the cloud. And then once you have your system set up with multiple microservices, you can use Kubernetes for orchestration and for controlling the operations of your backend service. So let's move on to the demo. So what I've prepared today is a Kanban board application that runs on all platforms, mobile, web, and desktop, of course written in Flutter, and connected to a local microservice backend running with one microservice running the Go API and the other running the Mongo database. And we use the Fiber framework on the backend side to implement the API. But yeah, the framework options on Go aren't really that important. I think the most popular ones are Fiber and Gin, but they're both quite simple, and there isn't really much to mention about them. So I guess it's up to you as to whether which one of these you choose. It's not like there is as much difference there as between Node.js and ASP.NET, for example. Let's go to VS Code now and begin with the Flutter app. So the first thing I have opened here is the entry point. So this is the global app object, and here you can define theme data and some global app state and the initial page that will be shown. I guess not that surprising as compared to other frameworks. Looking at the project structure, you will see that all of our cross-platform code is stored in the lib folder, and everything that's in it is written in Dart. So that means that there is no markup language used specifically for UI like XAML or HTML. And all of the UI has to be defined in the fluent syntax in Dart, which looks something like this. You can see that it's since you still have to maintain the hierarchy and in nested structures like in any other layout, this might get a bit hard to read. And that's the first disadvantage that comes to mind with Flutter is that you have to take extra care in separating everything into elements, into breaking everything up into different widgets, because otherwise you'll end up with a layout that's very hard to understand and to modify. But that's something to get used to. It's if you think about it, just regular programming practices, and once you get used to enforcing them a bit more, then it shouldn't be a problem. Speaking of the UI, the way Flutter does UI elements is that it considers every element a widget. In fact, even our global app is inherited from a widget, and that's the basic element for everything that you see on the screen. So this means that every widget that has some sort of a child property that you can put another level of elements in usually accepts a widget object, and since Flutter draws everything pixel by pixel, it has no problem putting any kind of widget in any level that you like. So and that puts it way ahead of frameworks that only offer native components for your UI. So previously, for example, if you wanted to put an image or a kind of a specially designed button in your navigation bar in your app, for example, it was a lot of platform-specific work that you would have to do for it, and sometimes it would not even be possible. But with Flutter, since everything is a widget and since Flutter draws everything by itself, it's the simplest thing ever to do. And so here, for example, with this elevated button, you see it has a child widget, which I only have set to text. But if I wanted to put an image in it as well, or I don't know, a loading spinner, all I could do is to wrap this up in another layout widget like a row and put some more components in it. And it would be as simple as that. So another thing you will notice on this widget is the state management, and that's a very big differentiator for Flutter because well, you might be wondering how with this pixel by pixel rendering, Flutter manages to maintain a close to native performance. And the key to that is that it's very strict about immutability and about enforcing state consistency. There are multiple patterns developed both by Flutter developers themselves and by the community that help you manage that. But I have a couple of examples of that here just to understand what this means for your work with Flutter. So the simplest state pattern is the stateful widget, which means that your UI component has a separate helper class that defines its state, sort of like a regular class in in any other language. But to modify anything in this state, you need to make an explicit call. So like this one here. If you need to modify something on the page, you call this setState callback, and only then will the Flutter engine re-render the page. So the render itself happens in this build override right here. And as opposed to some other frameworks where this build method would be called maybe multiple times a second or whenever any tiniest thing in the layout changes, in Flutter, the call to this build method is very deterministic, and it's only being done when you change the widget state that's defined here. And if your widget is stateless, like this app widget that I show at the beginning, then it will only be built once. You're guaranteed to only experience one render cycle with it. And this kind of determinism is really great for performance, but it puts an additional burden on developers to ensure that they update their state correctly and they maintain proper coding patterns to make this possible. And so stateful widget is just one example on how Flutter does this. And for the global app state, where I store user information and errors and so on, I'm using a different pattern, which is called provider. It's one of the more popular ones in the Flutter ecosystem. And here it's also has the same ideas that it has this immutable state that it's defining, and the only way to change it is to call this notify listeners callback. And only then will the subscriber widgets be re-rendered. So same idea, but slightly different package. Okay. Another thing I want to cover on the Flutter side is that this immutability paradigm also extends to models. So this is a task model that's used on our board. And the usual way to do this in Dart is to also make these models immutable. So you can see all fields are marked as final, and they are defined at construction time, which means that if you need to change something, you actually need to create a copy of this model with something like this, and this will recreate this object and with the updated state. And this ensures not only that your performance is maintained, but it also prevents your models from changing unexpectedly. So you know exactly where anything in the model changes. You can clearly see it from the code, and this is also expected to be maintained everywhere in the Flutter ecosystem, and actually even beyond that. I mean, immutability is a very common pattern in other languages as well, and generally a good practice to follow. And to wrap up on the Flutter part, other than the lib folder in our project, we have folders for each of the platforms that are supported. So, for example, Android, iOS, macOS, Linux, and so on. And what's great about it, and another thing that puts Flutter ahead of other cross-platform frameworks, is that every one of these folders contains a fully native project for that platform. So you see that there are some Kotlin files in here for Android. You have your Gradle, your Android manifest. And even greater, if you right-click on the folder itself, you have an option to open it in the native development environment for this platform. And this is great, first of all, if you want to provide some platform-specific logic that Flutter doesn't support. Thankfully, that's not something you'd have to do often, but something that I had to do for this app, because I've implemented authentication using Google Sign-In. And as it turns out, the support on the macOS for it is not quite complete, and it needs a bit more native code to ensure that it works. But with Flutter, it was very easy to add it to in native in a native environment in Swift to to the native project, and there are standard ways for it to communicate with the cross-platform code, and this means that even if you get into situations when you need some platform-specific handling, you have a very nice way to do that, and you don't have to rely on cross-platform bindings like you did with the Maui and Xamarin, where everything has to be in C# and everything is a .NET project. Here, everything is native, and like with Android, you can open this project in Xcode and manage stuff like signing, provision profiles, pod packages, yeah, whatever you need to handle on the native level, that's been made very easy with Flutter. Yep, and now let's move on to the backend side. So here is the Golang server that I have created. You can see the entry point here, and the setup is quite similar to how other web APIs would do it. So you connect to the database here, to Mongo in our case. You can set up some middleware for authentication and define endpoints for each of your APIs. So we have the user API here and the tasks API. So everything here should be quite similar. But where Go becomes very different is in how simple this syntax is. So I mentioned that it's not an object-oriented language. It only supports structures. And if you want to do something like a data service, where traditionally you would need a class, or actually first an interface and then a class with some state and some methods. In Go, you can only package this as a struct with some shared state, like the collection name here, and you just add your functions to it that can access this shared state. But other than that, they are almost completely standalone functions. And so this means that you don't really have any way to inherit services. You have some way to extend them, but much more limited than you would have with object-oriented languages. And that, again, enforces this way of thinking that you need to keep things as simple as possible and to package your API into multiple services. That's also something that you might find a bit harder to get used to at first, but it definitely has its benefits. And I was able to see them in my experience, how, especially with microservices, this kind of approach is really helpful. Same thing goes for models. It's a very simple struct with the data, and the only additional thing you can define are for the serialization. So you can define JSON names for your fields and BSON in case for Mongo. And so that's about it, really. So models are also kept very simple. And if you want to extend the model, that's also a bit harder to do in Go than it is in object-oriented languages. So you also need to keep that to a minimum. Here we have the API handler for tasks, which is called by the endpoints. And so we have this shared instance of the Mongo service struct that I showed you earlier. And it is stored in the same package here and initialized. So very, very simple kind of hierarchy here. And the handler also operates just as a set of functions with not even a shared state for them. But if you look into those functions specifically, you'd also see that it's really nothing special that's being done here, and it's quite familiar syntax for most of the time. Yep, I briefly already mentioned the authentication middleware, so there isn't really much more to say here, except that it's also something very similar to how other frameworks do it. But what's another great thing about Flutter is how it manages concurrency. So it doesn't really have constructions like async await or like those you would find in RxJS. Instead, it mostly uses something that's called channels, which are part of the language definition. And this operates sort of like asynchronous queues. And whenever you need to operate on some data in parallel, you can use native syntax to push data onto these channels. And yeah, I guess it's a bit harder to explain in detail in the time that we have. But basically, in the end, what that syntax helps you to do is that makes implementing something like WebSockets, which require a lot of parallelization, much more simple than you would expect. And you can see that by the size of this WebSocket service that it's really leverages these abilities quite well. And it also has thread safety functions for you to use if you need them. So yeah, that's also part that where Go makes things much simpler, but it also integrates them very deeply in the language. So you would be expected to use this quite a lot, and this should help you make your web API much more performant. So of course, all of these is packaged into containers in Docker. I have the bare minimum here. I have the our Go service itself, and it's pointing to another container which stores our database in Mongo. And you will see that I have Docker open here with this already running. Here are those two containers. And here I have Mongo Compass set up, which is the management UI for the Mongo databases. And here we have our two collections that you saw in the API. And yeah, if you're familiar with NoSQL databases, you will find this very familiar. And because the big advantage here is every one of these documents can have an entirely flexible schema. And that's great for microservices because you don't need to take care of coordinating schemas between services and performing stuff like migration is made much simpler with this approach. And like other databases, it's very scalable. It has index support, has replica sets, load balancing, you name it. So it's again, in my experience, has been a great choice for microservice-based data solutions. Right, so we've seen how this all looks like under the hood, and yeah, let's show you how this looks like in practice. So here in Flutter, I have this list of devices that I can use. You can see there's already quite a big choice, and if your device supports more options than that will be shown here, like Windows or Linux. But in this case, I'll start with with an Android emulator. I already have it set. And we can just start run the application. I have my emulator right here that I think you should be able to see. And yeah, in just a moment, the app should launch on this emulator. Yeah, there it is. It's taken a while. Okay, let's maybe try this again. I think there were some emulator issues here. Yes, now we're in. We have our landing page with the Google sign-in. It should already recognize my account. There it is. And here we see our board. So I mentioned that Flutter, since Flutter draws everything pixel by pixel, that ensures that your UI looks consistent across all platforms. But of course, you still need to account for screen sizes. There's really no getting away from that. And with Flutter, it's also very simple with something like Layout Builder, which monitors the size of the screen and can adjust the layout accordingly. So here I've made it so that on narrow screens, the dashboard shows like a carousel, which is similar to what you would see in something like Trello or Jira. But otherwise, it's a standard Kanban board. I'm sure you've all seen something like it. You can also view the task and create a new one. Yeah, I think that doesn't look so impressive so far. What makes Flutter especially great is that from that same code base, I can also build this app for macOS. And here it is. You can see it looks very similar, of course, except it's on a wider layout and it shows all columns at the same time. But then I also can run it on the web. And here I have my web application that's running from the same code base and shows the exactly same UI. And you might notice it's not 100% identical, maybe due to some resolution differences, but overall, it's all of them are using material components, and each one of them is drawn without any dependence on your platform. It's only dependent on the screen size. With the WebSocket support that we were able to add thanks to our Go API, if I move a task from one column to another, you will see it update immediately on all platforms. Same if I add a new one. Like so. Wait. And put it into to-do. You can see once I click create, it immediately appears everywhere. Same if I change the description. Like that. And that's the power of a cross-platform Flutter app development paired with a performant web API with using Go and MongoDB. And I think that's all I wanted to show on this side. So we can go back to the presentation. And now, just now to talk briefly about the business impact. Of course, you saw how a single code base can have a huge benefit to both to the speed of delivery and to your ability to use both AI tools and just dev tools in general. Right? Of course, puts much lower demands on your development team. And so, yeah, so the benefits are kind of obvious here, and they always have been, but the drawbacks, the trade-offs that you needed to make in user experience and performance are much smaller now than they used to be. And I think that should be the main takeaway here from this presentation is how much cross-platform frameworks have grown and how easy it is to create consistent experiences and to integrate them with the modern microservices backend. And yeah, together they provide a very nice experience both for users and for developers, and make sure that you can satisfy your business needs with the least amount of investment, and also, but also with the ability to expand it in future. Yes, and as to whether if you decide to move on with this kind of approach, and if you haven't really worked with either Flutter or cross-platform frameworks in general overall, the advice is always to start small, spend some time on a proof of concept and see for yourself the benefits of this approach. And yep, I think once you get going, you understand the benefits of it and how well they suit into your business needs. It's entirely possible that you might decide that it's not really worth the effort and a web-only approach is enough, which is also completely fine. But if you do choose to go with the cross-platform approach, you can feel safe knowing that the progress in that field has been enough so that you'll still be able to deliver a high quality product and not create an impression that you've cheaped out on your development resources by not going fully native. And of course, I mentioned that we at CIGen have a lot of experience with cross-platform development. So if you have a need for further assistance here, feel free to reach out to us for consultation. Yeah, I think that's all from my side, and we can move on to Q&A. Yeah, I don't really see any questions so far.
Yeah, so far also I can't see questions in the Q&A and in our chat. Yeah, so we have a comment from Roman. So Dmytro, it's a great presentation and got to try one of those Go backends. I think it's great.
Thanks.
Yeah. Also, Dmytro, can I ask you if you're sharing a presentation now to share it one more time?
Yep.
If you're the presentation slide, and let's give just a couple of minutes. Yeah, thank you. Now everything is perfect. Let's have a couple of minutes if we get more questions or comments. Yep. Well, we had a comment that it was great. So Dmytro, that was a great job done. That's absolutely true. And yeah, let's wait just a bit more before we slowly wrap up. We are sorry for any technical difficulties that might have occurred today for some of us, and we will definitely investigate a bit deeper into them to make sure that they will not be repeated next time. Yep, Dima, one more comment that it was great talk. Thank you. Yep. Okay. So I think that yeah, from our side, from CIGen side, we can thank you for joining us today, and I hope that this walkthrough gave you a clear picture of how Flutter, Go, and MongoDB can work together to support a unified cross-platform product, and maybe it even sparked a few ideas for your next project. If there is a specific technology you'd like us to explore in our future webinars, feel free to share it in the chat, or you can follow up afterwards. And we always appreciate your input. Also, let me share a link in our chat. Okay, shared. So you can also follow our LinkedIn page to stay updated on our upcoming sessions, industry insights, and the new content from our engineering team. So the link is in the chat. And thank you again for spending this time with us. And we look forward to seeing you at our next events. And have a nice evening, everybody. Thank you for joining. Okay.
Yep. Thanks, everyone.
Thank you, Dmytro.